Our story begins approximately 4.6 billion years ago, in a time when the universe was still young and full of potential. Imagine a vast, swirling cloud of gas and dust known as a nebula, stretching across the cosmos like a celestial canvas. This nebula, a stellar nursery of sorts, was the birthplace of our solar system, a place where stars and planets would eventually come to life. Gravity, the architect of the cosmos, worked tirelessly, pulling this interstellar material inwards, shaping the future of our solar neighborhood. As the nebula collapsed under its own gravity, it began to spin faster and faster, like a cosmic whirlpool drawing everything towards its center. This spinning motion caused the cloud to flatten into a rotating disk, a protoplanetary disk, where the seeds of planets were sown. At the center of this swirling disk, the material became incredibly dense and hot, a cauldron of creation. Temperatures and pressures soared, eventually reaching a critical point where the forces of nature would ignite a new star. This was the moment of ignition, a brilliant flash that signaled the birth of a new star. Nuclear fusion ignited in the heart of the collapsing nebula, releasing an incredible amount of energy, a beacon in the darkness of space. Our sun, a newborn star, blazed to life, illuminating the surrounding disk of dust and gas, a radiant beacon in the vastness of space. This marked the beginning of our solar system's long and fascinating journey, a journey that would eventually lead to the formation of planets, moons, and the diverse array of celestial bodies we see today. With the sun ablaze at the center, radiating immense energy and light, the remaining dust and gas in the protoplanetary disk began to clump together, driven by gravitational forces. This process, known as accretion, is fundamental to planet formation. It involves particles sticking together, gradually forming larger bodies. Microscopic particles, initially drawn together by electrostatic forces, began to collide and stick, forming larger and larger aggregates. Over millions of years, these aggregates grew into planetesimals, rocky bodies ranging in size from meters to kilometers. These planetesimals continued to collide and merge, forming even larger bodies. The inner solar system, closer to the sun, was hotter, preventing volatile compounds like water and methane from condensing. This intense heat played a crucial role in determining the composition of the forming planets. This led to the formation of the rocky inner planets, including Mercury, Venus, Earth, and Mars. These planets are composed primarily of silicate rocks and metals. Further out, beyond the frost line, temperatures were cold enough for ices to remain solid. This region allowed for the accumulation of not just rock, but also ices like water, ammonia, and methane. This allowed the gas giants, Jupiter, Saturn, Uranus, and Neptune, to accrete vast amounts of gas along with their rocky and icy cores. These massive planets have thick atmospheres composed mainly of hydrogen and helium. The stage was set for the dramatic events that would shape our young planet. Collisions, volcanic activity, and the eventual cooling of the Earth's surface would lead to the formation of a habitable world. The Hadean Eon, named after the Greek underworld Hades, aptly describes the early Earth's environment. This period was marked by extreme conditions that were both violent and chaotic. Spanning from about 4.6 to 4 billion years ago, the Hadean Eon was a time of intense heat, relentless volcanic activity, and frequent bombardment from asteroids and comets. These cosmic collisions were so powerful that they reshaped the planet's surface repeatedly. The young Earth was a molten inferno, a fiery landscape where temperatures soared and the ground was in a constant state of flux. Its surface was a vast magma ocean, constantly churned by volcanic eruptions and impacts from space. These impacts not only created craters but also contributed to the mixing and melting of the surface. The atmosphere was a toxic cocktail of gases, devoid of free oxygen. It was filled with volcanic gases like sulfur dioxide and carbon dioxide, making it inhospitable for any form of life as we know it. It was a hostile and unforgiving environment, far from the life-sustaining planet we know today. The surface was barren and the air was thick with noxious fumes. Despite this chaotic environment, the seeds of change were being sown. Slowly but surely, the Earth began to cool, setting the stage for the next phase of its transformation. As Earth slowly cooled, its molten surface began to solidify, forming the first primitive crust. This crust was fragile and frequently disrupted by ongoing volcanic activity and impacts. The stage was set for a truly momentous event, the formation of our moon. This celestial body would play a crucial role in stabilizing the Earth's rotation and influencing its future development. The origin of our moon has intrigued scientists for centuries. The prevailing theory, supported by a wealth of evidence, suggests a cataclysmic event early in Earth's history. Around 4.5 billion years ago, a Mars-sized object, often called Theia, collided with the young Earth. This impact was colossal, releasing an unimaginable amount of energy. Theia was obliterated and a significant portion of Earth's mantle was ejected into space. This debris, caught in Earth's gravitational pull, coalesced over time to form our moon. The moon's formation had profound implications for Earth. Its gravitational influence stabilized Earth's rotation, creating the regular seasons we experience today. It also played a crucial role in the development of life by influencing tides and ocean currents. Section 5. Oceans emerge, cooling down and filling up. As Earth continued to cool, its surface temperature dropped below the boiling point of water. Water vapor in the atmosphere condensed, forming clouds and unleashing torrential rains that lasted for millennia. These rains filled the planet's basins, creating the first oceans. The early oceans were far from the serene blue expanses we know today. They were hot, acidic, and rich in dissolved minerals. However, they provided a crucial ingredient for life, a stable environment where complex molecules could form and interact. The emergence of oceans marked a turning point in Earth's history. It set the stage for the next chapter in our planet's story, the emergence of life. Section 6. Life finds a foothold, the first whispers of biology. The exact details of how life arose from non-living matter remain one of science's greatest mysteries. However, we know that around 3.5 to 4 billion years ago, in the depths of Earth's primordial oceans, life emerged. The first life forms were simple single-celled organisms, likely resembling bacteria or archaea. These early microbes thrived in the harsh conditions of the early Earth, harnessing energy from chemical reactions or sunlight. Over billions of years, life diversified and evolved. Photosynthesis evolved, releasing oxygen into the atmosphere and paving the way for more complex life forms to emerge. The stage was set for the rise of multicellular organisms and the incredible diversity of life we see today. Section 7. Dinosaurs rule a Mesozoic Majesty. The Mesozoic era, spanning from about 252 to 66 million years ago, is often referred to as the Age of Dinosaurs. During this time, dinosaurs, a diverse group of reptiles, evolved into a bewildering array of shapes and sizes. From the mighty Tyrannosaurus rex to the long-necked Brachiosaurus, dinosaurs ruled the planet for over 180 million years. They inhabited a world vastly different from our own, with warmer temperatures and higher sea levels. The reign of the dinosaurs came to an abrupt end 66 million years ago when a massive asteroid slammed into Earth. This catastrophic event triggered widespread wildfires, tsunamis, and a global impact winter, wiping out an estimated 76% of all plant and animal species, including the dinosaurs. Section 8. The rise of mammals after the asteroid opportunity. The extinction of the dinosaurs created an ecological void that allowed mammals to flourish. Mammals, small and relatively insignificant during the reign of the dinosaurs, were able to adapt and diversify in the post-apocalyptic world. Over millions of years, mammals evolved into a diverse array of forms, from tiny shrews to giant whales. They colonized land, air, and sea, taking advantage of the ecological niches left vacant by the dinosaurs. Among these mammals were the primates, our own ancestors. These tree-dwelling creatures possessed grasping hands, binocular vision, and large brains, traits that would prove crucial for their descendants' eventual dominance. Section 9. Earth's everlasting evolution, a story still being written. The story of Earth is a testament to the power of change. From its fiery birth to the emergence of life and the rise and fall of countless species, our planet has been in a constant state of flux. Today, Earth faces new challenges, many of our own making. Climate change, habitat loss, and pollution threaten the delicate balance of our planet's ecosystems. However, just as it has for billions of years, life will adapt and evolve. The future of Earth and of humanity depends on our understanding of our planet's past and our willingness to act as stewards of its future. The story of Earth is far from over. We are writing the next chapter.